Hello everyone, welcome to part 2 of the setup video. This is gonna be so that you can easily follow my future streams. In fact, the stream, I don't intend to make them too much as kind of tutorials, but I just want those of you that would like to create similar things to have access to the libraries, but also stuff that I wrote directly. So different kinds of, I call these kind of modules that I wrote. They're far from perfect and they're just very basic. But after this video, I'll provide a repository where you can get the version of these modules as it stands. So that, as soon as I start uploading my streams to this platform, you can easily kind of see where this extra code that I'm using is coming from. So that's the idea with today, part 2 of the setup. Now it's gonna be a little bit shorter, I hope, because the last video was really kind of long, but I'm glad I went through everything, and I'm sure at least perhaps one person will find this video useful, and that's already enough. So basically I use a few extra modules that are already written, and I already kind of test some stuff with these, and some of these are just kind of basic simple modules, and some are a little bit more complex. So I'm just gonna start by bringing all of the modules. What I do is I bring all the modules directly in my depths folder. So I'm gonna paste all my modules. Each module is just a C and an H file. And in my CMake list for the project, I will kind of add an extra part of the code. So let me just show you. I'm gonna add to the CMake list. And just before I compile the smaller library statically, where I build I showed you in the other video, where I added, we're gonna build our modules here, is where we're gonna do this step. So basically we're gonna check for our own module, my module include. We're going to kind of take everything in the depths directory directly. So not any, because the way I organize the project is I put all my own modules directly in depths, and then libraries and kind of subfolders of depths. It's just a personal way to organize. Just choose your own way, So then if that exists, so should usually exist, otherwise something else will have failed. But still, if it exists, we're gonna print a little message. So we're gonna say we're building the modules statically, for example. And then we're going to create one big library with all the modules called my modules static library. And I'm going to be using I'm going to list every H file, and we'll go through these H file very soon. So first of all, there's animation. This is actually empty for now because of previous design decisions, but the H file contains some useful structures. The log is very useful just for basic logging. We have the sprite atlas, which is it needs some reworking because I had to disable a feature because of a bug temporarily, but basically it's a virtual texture creator, if you want. It just takes a bunch of files and it creates virtual textures, so it works fairly well. we have TextMan, which is just a wrapper around the text engine in SDL3. So it's just kind of like the same thing as the Sprite Atlas for fonts, but I used to have my own glyph atlas, but now that SDL has their text engine, I just kind of created a wrapper around it. So this text manager, TextMan. We have InputMan. That's the input manager. The way that this works is it has some key debouncing, so kind of like a mechanism where if you press a key, it doesn't kind of react right away. It kind of stacks up, and then it reacts after a certain threshold. So the input manager has this kind of key debouncing mechanism, and I tried to design it so you could hook up different kind of function pointers to different trigger if you want. But anyway, not perfect, but that's what it does. We have profiling, which is just for measuring the frame duration and everything. And I have a utility with a bunch of little functions that I'm probably going to replace, or because I know there's a bunch of interesting kind of available set of these functions that already exist. Like I'm looking at there's Eskil Steenberg that made available kind of all of his coding libraries, and he has some interesting stuff there. So I might eventually replace that, but for now it's my own utilities there. So basic like linear interpolation and remapping a range, a value to another value range and stuff like that, you know. Then we have target compile option, sorry. And we want to specify that just compile this as std C99, just to be sure. Then we are going to include the directories that we need. So my dependencies require SDL if we want in the grand scheme of things, and also there's some mlib containers in there, so you have to include mlib for it to work. And then you can just link these libraries, which is just SDL basically. So we're gonna link. We are using SDL3. I don't know why it keeps like indenting in a weird way. We're using SDL3 image. And we're using SDL3 TTF in that. That's for the text manager. And after we're done with this, what we're doing is we're setting the target properties of the my modules library. And as a properties, we're gonna set this, which is called the archive output directory, and that's gonna be CMake binary there and depth. There we go. That's just that kind of stores the static library in the directory after it's built. And if we can't find any modules, we're gonna print a message. That's gonna be a fatal error as well, and that's gonna be couldn't find modules for static build, and then end if. There we go. So that's gonna build all of these. We also need to go down there and include the modules. So my modules include And we also need to link with the modules, my modules. There. So you can see it's very easy. I know there's a lot of people that don't like CMake, but personally, I was really bad at CMake, but when they came out with the large language model like ChatGPT and stuff, it's really useful because you can, these frameworks are really big, but once you figure out how certain things interact, it's actually fairly easy to express certain build concepts for now, at least from what I've seen. So I like it from what I've seen. There's some limitations, but once you pick up some of the tricks, it's pretty neat. Let's rerun the CMake. Oh, it wasn't. It's my bad. I built without running the CMake, so that's why there was an inconsistency. Now we have the modules being generated. So yeah, everything's fine. Sometimes it's easy to get a little bit confused with these larger systems. Alright, so you can see basically once you get access to my repo, you'll be able to get these. So that's covered essentially. And now the only last thing I want to do is I kind of want to bring this project, which is kind of just a demo that I was kind of showcasing for the purpose of these set of videos. I want to bring it to the exact same state as another project that I have, which is actually not very advanced. So that's what I'm going to do now, is I'm just going to kind of make sure that the source match up, so that once I start uploading a stream where I develop my project, you're able to kind of pick up from the very beginning if you want. Alright, so basically I just want to do a few things. So one of the things I want to do is I want to just show and demonstrate the Sprite Atlas, how it works, and how we can kind of build it and use it. So it's going to be pretty simple, I think, because of the way I wrote it. It's not too difficult. So I'm just going to have a structure Sprite Atlas. Call it Sprite Atlas, or just Atlas. And down into the code, if we scroll down into the main function, I'm going to initialize the atlas. So the way that it can be done is I have this function satlas init. You need to provide your renderer, your SDL renderer, and then a pointer to Sprite Atlas pointer. So you provide a pointer to Atlas. So that kind of creates the atlas there. Pretty straightforward. Then the way I'm gonna do it for now is I'm just gonna kind of bring in a few basic images. You could use any image, because this is just a stream where I develop my own project. I won't be sharing the project externally anyway, so it's public for the sake of knowledge sharing. But yeah, you can make your own images or create a similar game using the same kind of ideas that I'm going to be showcasing during the streams. And so yeah, I'm just going to bring a bunch of images. The way I'll do it is I'll just create a new subfolder in the DAT called GFX, and then I'm going to bring a bunch of image there, just basic image. And then in the code, the way that I do it is I have this in my Sprite Atlas, I have Sprite Atlas directory to Sprite Sheets. like this. And so the way that it works is you provide your atlas, you provide a directory for the atlas. For this case, it's dat/dfx. So that's the directory that's going to load into sprite sheets. Then you specify if you want to kind of continue using previous sprite sheet with this this mechanism, or if you want to start a new kind of set of sprite sheets right away, because each sprite sheet has kind of like a naming tag that you can use for it. So you can either kind of choose to you kind of use the incomplete sprite sheet that was left behind, or you start fresh right away with a new naming convention. Depends on what you want to do, but for me, I set to false. And then I'm going to use string CTE, which is a way to create creates a string, temporary, I believe, hopefully. I have to check, actually, make sure that the memory, I don't have to do something with it. We'll deal with this later when we actually continue the stream. So yeah, this kind of creates, this is going to create as many spreadsheets as are needed to support all the files in the directory, and the spreadsheets are going to start with test and then _0, 1, 2, 3, 4, 5. So that's how it works. So just as a demonstration, after that, I'm going to show you how to dump the whole atlas. So I'm going to get a first sheet, and then I'm going to use satlas sheet get by name, and I'm gonna get from the atlas. Sorry, I'm gonna get the same test. Oops, my cat's waking up, and then that's gonna give me the sheet. So I'm also gonna get dimensions of the texture of the atlas. And I'll have to be right back. Sorry. So I'm gonna get the texture size of the atlas, and yeah, that's gonna be I'm gonna draw that. We can do this a little bit later, actually, maybe just before the event. Sorry, I messed up. There we go. So like this, and then if you want to just show the atlas, just to, for the sake of it, oops, sorry, we'll do a render texture here, and we'll use the sheet, all of it, and we'll use a pointer to this temporary rectangle, which is going to contain, we're gonna put it at 10, 10, and then we need the texture size. That's how we do it. So, there's gonna be some issue. So one of the issue is that, as you can see, when I use my sprite atlas, it says that there's an undefined reference to debug log, and the reason for this is that basically I need to use log.h, which is my log script, because the sprite atlas relies on not really including log.h. The include is done by the atlas itself, but if you go through log.h, you'll see that you have to define a constant called debug log, and you have to define it to a specific value. So let's use a value of none. So let's say that it's equal to none. Sorry, it's a type int. There we go. It's a type int, I guess. Not const. Sorry. There we go. Sorry, it's been a little bit since I set it up, but so yeah, because what you want is defining this value. There's three values that I have. So there's debug log none, there's check and spam, and it's just three kind of seriousness level that I turn on depending on what I'm trying to do. It can be useful sometimes to like have these extra printf, not really printf, but like, you know, logging that you can kind of disable but enable if you're looking for a source of an issue. That it can be hard to track from time to time, or at least I find it useful. So this is what's happening there. So if we rebuild, it's going to be good. Now we also need to rerun this CMake script, because the CMake script is going to copy the data into the build directory, and otherwise we won't be able to find the files. So I'm going to CMake and click this little reload. And now the content of data contains the new files. And now we can play, and you can see we have all the images there from the atlas being placed at 1010 with the proper definition. So yeah, that's something I wanted to demonstrate. We're gonna modify the atlas eventually. You can see if you go in spriteatlas.h, this is where you can define some of the parameter. For now, it's a very basic system, you know, I made it myself. If you see these error, type union is incomplete, you can just ignore them. This is a false positive that I've already signaled to C99, but haven't seen a fix yet. So it's because of the way that mlib uses a lot of macros to generate a bunch of stuff, and for some reason C99 doesn't like that with their new Nova engine, which is if you go to your settings, advanced setting, C99 use the ReSharper C++ language engine. So this is kind of like where this false positive is coming from. All right, so that's cool. It's cool. So yeah, there's just a few things that I want to adjust, just a few things. So in this component for the box, I'm going to kind of add a few behaviors. The first thing is that on this computer specifically, I have kind of I have a higher DPI value, so everything is scaled by 200%. So this causes me a lot of issues because of the kind of gain that I'm trying to make. So I know you could use logical size to kind of fix this issue in a very kind of broad way, but it just doesn't work for what I'm trying to do with pixel art and very wide display and different kind of size of display. So for this reason, in this component that I already kind of started working on last time, I'm going to add these two boolean that kind of take care of resizing the component position and bounds depending on the DPI scale. And you just have two boolean there essentially. In the box constructor, by default, I'll specify both of these to true. So that's going to make it a little bit more straightforward, because most objects are going to want to be scaled up, I think. Since this is such a kind of broad kind of property, the DPI scaling applies on everything. So some objects you don't want to, like the mouse, you don't want to scale the mouse coordinates, but it's very situational. So that's good. Also, We don't need to do that. What am I doing? Also, basically, the idea is that when we go here and we start drawing, here we get the final position and the final bounds. So the final, instead of final position, we'll call this the origin position, essentially. And you know, actually, we don't need to change the name right now. I'm just kind of going ahead of myself there. Sorry. The first thing we're going to do is we're going to check if the booleans are true, and if they're true, we're going to take these final positions and we're going to multiply them by this DPI scale. Now, this DPI scale, I don't have any value. Actually, I already have a value for it up here, but I think that's something I might have done by accident off camera. So it's good that we added it. I'm going to show it in a second. And then our bounds DPI scale true. Sorry. Destroying everything. Classic. This is going to be y, and this is going to be final bounds x and y. So you see what I'm doing? I'm just checking this boolean and increasing it by a DPI scale. Now, what is DPI scale? It's this value here that we get from the window with SDL, which gets us this value, like how much of the window resolution, how much of a multiplier is applied to all the elements in the window. It's the kind of thing you get when you go here in your display settings, and then you see here at 200%. So this is, mine is going to be 2. Essentially, that's the window display scale is 2. So I need to modify all my graphics, multiplying them by that value, so that my display is consistent across displays. Now it will break down on half displays, like 150% will look bad because I'm using a pixel art style for this project, but the user has to fix that problem. Most people won't have that problem, I think. People that play at that have 200% screen are the one I'm targeting with this fix, or this consideration, essentially. So maybe it's gonna turn out to be a bad idea eventually, but for now, that's what I'm doing. So that's great. It's going to make it. Oh, also, I have to do that before creating the draw rect. There we go. And then finally, you can see that now my rectangle is much bigger. I'm going to disable the atlas, the line here, that for the atlas, so we can see better. So I want to do a few last touches so that this project is just at the same state as my other scripts, so that when I start my stream next time, anyone that wants to have all the required information has it. And then I'm gonna cut off soon after, so we have a little bit more time left and then we're done. So the next thing I want to do is I want to add a few extra things to my box component that I'm starting to program in with the Flex library. I want to add a boolean about whether or not I'm going to be showing the origin as a debug point, and another boolean about whether or not the box should be drawn from its center instead of its top left corner. Eventually I might change this for an anchoring system. So by default, the box, we're going to say that it's showing its origin, and we're going to say that for now it's not being drawn from its top left corner, from its center, sorry. For the origin, it's very easy. So after you draw the rectangle here, in the system draw boxes, which I should probably rename soon, we're gonna check the box we're gonna check if the box is supposed to be showing its origin, and if so, we're gonna set the render draw color to green. So I have to pick my renderer, and then we will be rendering a rectangle. So basically the way I'm going to do it is I'm going to create a point, a rectangle, sorry, called big point, and that's going to be a rectangle that is at the same position as my final position. But it has a size of 1, so it's a very small rectangle. So I'm going to use the address of big point, which is fine, and then render that this really small rectangle. And what's going to happen now is that I'm going to have a green. Oh, actually, I seemingly don't have it for some reason. So it's showing origin true. Actually, there's a few problems also. We shouldn't continue here. We should just do an else and then do that. That'll be better. That's not the problem too. Am I even hitting that point? Let's just verify real quick. Yeah, we are. Maybe it's just too small to be seen. Let's do let's render 3 by 3 and let's use fill rect. That's gonna be more better. That's gonna be better. Yeah, I can see it. It's just too small. Let's do the thing is that this size here, it almost needs to be, we almost need to look if about, we should probably look for the bound scaling, and if the bound scaling is true, we take the big point and do the same thing. I think that's gonna be what we want. There you go. Because on my screen it's super tiny. Actually it's the W and H that we want to fix. There we go. So now we can see this little green dot, which represents the origin at which we're drawing. And finally, we're gonna deal with is drawn from center. So we're gonna set it to true. And what we're gonna do now is this is gonna be the origin position. Sorry about the cat. I'm about to finish, so I'll wait. So yeah, I'm gonna do call this the origin position. Then we're gonna basically multiply it by the DPI scale. And then what I'm gonna be doing is I'm gonna be creating another value called the final position, and you'll see why I need to do that. And I'm gonna set it to the origin position. So I want to keep the origin position separately because I'll need it later for drawing the green point. But what I'm gonna do is calculate a different position to draw the rectangle at. So I'm gonna check if we're supposed to draw from the center, and then if it's true, I'm going to calculate that the final position should be kind of offset by negative of half the width, and same same for the height. So half of the height should be offset. Position should be offset by half of the height. There we go. Like this. And so the thing is that at the end here, where we use the big point, we are going to use the origin position there. So that's going to make it so that we can more easily visualize. And this rectangle, we should draw it after here, like this, and that. So yeah, that's my train of thought. I was going to say that we'll need the origin position to draw the big point properly. But the final position, which is offset by half of the size of the box that we're drawing, that's going to be used to draw the actual rectangle. So results is that we draw from the center now. So the position we give is the center of the rectangle, if we want. So now that's how the system works. You can see, by the way, it's really cool that it's a system. I can just create more rectangle and more box, add them to more component, and they're going to be drawn, and so on. Nice. So so yeah, this system that I have there is gonna change a little bit. For now, I think it's pretty good. I think I'm gonna. The last thing I want to do is I just want to add two basic tags. So my idea is that this system, instead of drawing boxes, I'm gonna call it draw UI boxes, essentially. And so what I'm gonna do is just it's kind of like a micro demonstration as well. And I'm going to kind of wrap up with this, and then next time I'm going to be streaming, it's going to be kind of a full-on development stream where, at least with these two starter videos, you can kind of use that plus my stream to see what I'm doing. And so I'm going to create two tags. One is going to be the draw batch, so which kind of batch of rendering is that going to be part of, and then we're going to add another tag in the ECS for a screen like that. So what we're going to do is, in the new entity that we're creating, which is this new entity here, which for example we could just call the viewport there, just for the sake of it. So I'm going to do ECS add pair. I'm gonna add to the viewport. The draw batch is the screen, so I'm gonna add two tags, kind of like a relationship there, like this. And here, this system, what I'm gonna do is I'm gonna say that it can only run with the specified, if the pair is specified, essentially. So the way that I'll do this is I'll rewrite this a little bit differently, actually. So I'm going to call the system differently. So I'm going to specify it into the ECS. Then I'm going to say that there's going to be a new entity matching that system. So each system is an entity in that framework. So I'm going to create a new entity. Oops. So the name is going to be draw UI, just for now. We're gonna add the system to the onUpdate. Now we're going to specify the terms of the system. So the first term is a box component, and the second term is the pair. So I'm gonna do it like that. I'm gonna do a lookup for both members of the pair for now. It's gonna be a better way eventually, but this is how I did it in my off-screen example. So I just want to match up so I can start streaming and have everything in order. And finally, the callback is system draw UI boxes. Like this. So very, very elaborate call. And this is how it looks. Specifying the system now with a pair, a little bit more kind of explicitly. We're gonna call it draw UI boxes. So now if I press play, you can see the box is still being drawn. But if I, for example, remove the box here, let's say I create a new tag called game. So we can render the game or the screen, and I tag this box as a game, as part of the game. Now it won't render. You know? So I can kind of have this system. This system will only work when the batch is screened, essentially. So that's going to give me a little bit more granular control over some systems, and I'm gonna try to share some logic somehow, because I don't want to write like multiple systems that do the same thing. So I'll just think about different approaches. So yeah, so that's pretty good in that case. There's not really that much else I want to show. So I think next time I'll just be streaming, and I'll kind of be developing my project a little bit more. And hopefully you found these set of videos a little bit insightful. I don't know if it was too much, but at least it's available, and if you ever want this information is out there in the world. Oh, there's also a small bug. The color here in the component needs to be an unsigned value. So I noticed that before. So just correct that right there. Alright, so thanks for watching, and hopefully you can pick up the stream whenever, and I'll be kind of uploading the stream as an ongoing series on the channel. So yeah, have a good one.